Hello, my name is Hannah and I'm a PhD candidate at the University of Guelph. I'm happy to have the opportunity today to discuss some of my research with you where we are using physiological measures to evaluate weaned piglet welfare after long and short transport durations. To begin with some background, we know that in North America, commercial piglets are often transported between farm sites after weaning in order to prevent disease. We also know that Canadian transport regulations are informed heavily by data from market hog research. However, very few studies have investigated the effects of long transport times on weaned piglet welfare. It's understood that increasing transport duration increases piglets' exposure to both the trailer environment and the length of time without access to feed and water. And so our question is, how does long versus short transport impact young piglet welfare? The objective of our research was to compare physiological changes in piglets undergoing Canadian commercial transport after weaning for long and short durations. In order to answer our research question, we collected weights, injury scores, and blood samples from piglets from 2 production systems over multiple transport events during the summer of 2019. In total, we directly sampled 240 piglets from the over 9,000 transported for long durations and 200 piglets from the over 2,000 transported for short durations. We sampled piglets the day before, immediately after, and 3 to 4 days after transport. Moving into results, we found that long-duration piglets lost a greater percent of their body weight over transport compared to short-duration piglets. At arrival, long-duration piglets weighed about 0.4 kilograms less than short-duration piglets. However, there was no difference between the groups by 3 to 4 days after arrival. Looking at our lesion and lameness scores, we were encouraged to find that injury scores recorded at all of our time points were low for both groups, with the exception of ear lesions. We were also pleased to see that there were similar changes in injury scores from pre-transport to arrival for both of our groups. Finally, looking at the results of our blood parameters, we observed that piglets undergoing short-duration transport had an increased stress response compared to piglets undergoing long-duration transport, as indicated by increased serum cortisol levels and increased neutrophil to lymphocyte ratios after transport compared to the long-duration piglets. We also saw that short-duration piglets showed evidence of increased muscle strain relative to LD piglets, as their levels of aspartate aminotransferase and creatine kinase were greater after transport. However, these muscle injury indicators were within normal range for this age group. After transport, the LD piglets did show evidence of increased dehydration relative to the SD piglets, as indicated through higher hematocrit levels, but again, average values of these blood indicators of hydration were within normal ranges for these piglets. In conclusion, physiological changes were observed in both long and short transported piglets in this study. And while we saw different changes in hydration status, stress response, and muscle strain between our duration groups, we feel that neither transport duration resulted in adverse physiological responses in our sampled piglets because these parameters were within normal ranges for pigs of this age group. Research investigating the effect of these durations on piglet physiology during transport under Canadian winter conditions would be valuable as a next step, as environmental conditions may be more challenging to piglet welfare in the winter. I'd like to wrap up by thanking Swine Innovation Porc for their financial support of this project, and all of our participating producers, as well as Ollie Mel. I'd like to thank you for your interest in the project today, and hope you enjoy the rest of the meeting. Thank you.